Thank you, Eugene. And thank you, everybody, for coming. I was telling Eugene just before we started that there's this feeling of butterflies you have before you give the first talk of a symposium as to how many people are going to be showing up. When we have this Teams-based system, it seems to me that there's no way to predict. So I appreciate your being here. Thank you very much, everybody. I'm going to talk a bit today about where I think we are in GenAI working with TechCom, but I want to talk about it with two major theses. The first one is that I believe we have a new deliverable for the field of TechCom. For decades, we've had documents and documentation systems that we deliver as documents. In the late 90s and early 2000s, we began to see search becoming much more popular. People didn't want to read through long document systems. They really wanted to search and just find a short passage that reflected what they were looking for. But for a number of reasons, neither document reading and browsing or search met all of our specific needs. And so what I want to suggest is coming, and I'm going to show a few examples that already exist today, for documentation, is a system which operates in a third deliverable, the chatbot interface. And I want to argue that this is going to have a significant impact for how we research, how we teach, and how we develop technical communication products. But in order to get there, I want to review sort of the current state of discussions and debates inside the field. We have Dr. Sauer's keynote speech last year that I think opened up the conversation about the importance of GenAI in TechCom well. Stuart argued that we need to study GenAI technologies more, and he produced his 5 tenets for the reasons why these things are going to be very important to us in our field. But then a month later, we had Jennifer Sanofrancini and Megan McIntyre and Maggie Fernandez's piece, which argued that we should have an ethical means of refusing to use GenAI entirely. And they produced 10 arguments why they suggested that there are very strong reasons why one might reject using the GenAIs that are available to us, the ChatGPTs, the Anthropic Claudes, the Google Geminis. And I want to take seriously their arguments as well. So here I am stuck giving a keynote presentation. I've got 2 somewhat incommensurable dominant positions about how we should think about this field. And I'm stuck needing to come up with some third alternative that allows us to work in GenAI while also taking seriously concerns and considerations about that field. This is where I was a month ago when I started working earnestly on this paper. What could that third option be? And I'm going to argue in this paper that the third option is something which comes from fog computing. And I'm going to suggest that there's a kind of fog GenAI, which, if you aren't familiar with it, I'll present to you today. I'll show you how that might enable us to thread the needle to take seriously both the pro GenAI and cloud GenAI positions, as well as those which are concerned and hesitant about those, and then talk about ways in which we can do substantive teaching and research with GenAIs, while also taking seriously some well-founded concerns and doubts about them. So let's see how it goes. I'll start by talking about some things that have happened since last year's keynote speech that I think are good arguments for why we should adopt cloud GenAI. And the first one I'm going to take comes from, I'm going to use a Jason Swartz 2015 article, which has haunted me. This is the first year I joined the Technical Communication Quarterly editorial board, and I read the piece. And it left me feeling sad and empty, as some of the best articles sometimes do. Swartz argued that documentation systems, the way we built them, are not very likable. That we can do a lot of work with them, and there's a lot of ways in which people engage in the work. But he took a look at the way in which, in a networked age, we have to think about how it is people interact with documents or want to interact with documents. In some ways, taking his piece, we could think about it with an Aristotelian sort of model. According to Swartz's argument, which I think is highly persuasive, documentation has historically been good at ethos and good at logos, but we've been really terrible at pathos. I have a colleague, an old friend, whose wife worked for Microsoft, producing the early documentation for Microsoft in the 1970s, in the late 70s and early 80s. She was one of the first employees. And she talked to me at length in a jazz club in Seattle one time about how shocked they were by the fact that the Microsoft handbooks came with sort of 500 pages worth of documentation. People paid a ton of money for the Microsoft Office suite, for instance. But then people would pay an additional $25 for the For Dummies books, which were cartoonish and pleasant and fun, but were very different than the official documentation. It seems to me, if we want to take a lesson from that at all, pathos is one of those things that we could really benefit from. And winning the pathos argument, I would argue very strongly, are chatbot interfaces like ChatGPT. I've got here a TikTok video with tens of millions of viewers in which our protagonist argues, I love him so much, and has this animated ChatGPT character who is her friend. The New York Times has an article that suggests the same thing. It sort of has the she's in love with GPT from February, I think. No, sorry, this is a January article. And it suggests, it sort of documents these people in their 20s who love their interactions with chatbot interfaces like ChatGPT. I can tell you without getting too personal that I took my 11-year-old to the emergency room last night. She cut her hand accidentally, and it was a deep cut, so I took her to the ER because that's what I do as a dad. And as she's waiting in the emergency room, in the room for the doctor to come, she opens up with her left hand, which isn't cut, ChatGPT to ask how much stitches hurt relative to the hurting yourself by cutting your hand. People love their chatbot interfaces. Kyung Jen in peer-reviewed scholarly journals is talking here in the Journal of Business Research in another 2025 article here about the possibility that users will fall in love with ChatGPT. What it provides for users is infinite attention, no demands, and as much time as users want to give it. It's the sort of ultimate extension of the work in user-centered design and in the focus of user attention that we've been seeing increase with social media apps in various ways over the past few decades. And I want to suggest here that, sorry, I'm looking at the chat, I don't want to get distracted, that there might be a way in which if we move documentation genres into chatbot interfaces, we can shore up the third leg of our stool and produce documentation that people might actually like to use. But, you know, if there are good reasons why we should be doing this work, we need to take seriously the refuse argument. One good argument for that comes from scholarly literature. As the cloud GenAIs have gone to bigger and bigger models, the new GPT 4.5 theoretically by reports seems to have about 2.25 trillion parameters inside of its model. Now, as models get bigger and bigger, we have the increasing danger of hallucination, of the GenAI giving us incorrect answers. And they come from out of context perspectives. If you ask a GenAI about size, and it's reading documents on cosmology, it's going to be thinking about answers in terms of light years, or hundreds of light years, or thousands of light years. If you ask it a question and it's reading from documents about architecture, it's going to be looking at answers in the tens of meters or maybe hundreds of meters. If you ask it a question and it's reading documents about microprocessor architecture, it's going to be looking at answers that are in the nanometer and in the picometer in the years to come. Now we're down to almost 2 nanometer designs. And when it uses all of those sources for its answers, it may provide answers that come from out of context perspectives. The bigger the parameters for the model get, the more likely it is that hallucination is going to happen, and the more difficult it is for those of us who want to put documentation into those systems. They're simply sometimes going to give us wrong answers. Geoffrey, in this article, suggests that's going to necessarily happen. But as we look at the CEOs of the large tech cloud GenAI companies, people like Sam Altman at OpenAI and Dario Amodei of Anthropic, we see that they are dedicated and focused on building larger and larger models. This is their ambition. In his 2024, Amodei calls it a book. It's a 13,000 word blog post. When I do the math, I want to put sort of quotations around the book, but we should take him seriously. In his 2024 book, Machines of Loving Grace, Hamadeh talks about both the dangers, but also the enormous opportunities he sees as these Gen AIs get bigger and bigger. He believes that they're going to get more and more capable of answering questions that are important to us. And as we start to think about refusing these things, we want to think about whether the interests of tech bro oligarchical cloud service providers like Altman or Hamadeh actually represent our interests as technical communicators and our users' interests as users of these pieces. As we begin to take seriously things like the environmental costs and the power supply costs and the water usage necessary for the sort of large scale Gen AI models. We could take a look at reference sites like Hugging Face's CO2 cost models, which show in hundreds of kilograms the CO2 cost of various dominant models right now. Okay, so before I talk about why I think my answer allows us to thread those discordant perspectives, and why it's not, I think the chat has tried to talk about a way in which we might advocate for a critical perspective, but I find if you don't, and the critical perspective is a direction we tend to want to go, but let me take a look briefly at the intricacies of how LLMs work, because it may be in there we can find something which is going to be a little bit more specific, a little bit more practical, a little bit more direct than simply advocating for critical use of Gen AIs, which is a good start, but let me show you what I want to do instead. I'm going to patronize you, I'm sorry, briefly. I hesitate to do this, but I want to go through how these models work so that I can show you the space in which I think there's an opportunity for us to intervene. So you know this model, right? You're using your laptop connecting to a web interface with chatgpt.com. You ask it questions and it posts the answers inside the website. This is the simplest way that Gen AIs work. In fact, it's a little more complicated than that because OpenAI has this web front end, which is the chatgpt.com site. But in fact, it's then relaying the questions you type into the chatbot into a backend LLM. In this case, I'm showing GPT-4o Mini, but they have a bunch of LLMs that they can select from or that paid users can sometimes select from, so they can pick the ones they prefer to use. Those are separate from each other. The web interface is a completely separate piece of software from the backend LLM, and they talk to each other using a standard protocol called the OpenAPI protocol mostly. And as a result, there's some implications from that we need to think about. On top of that, we have the ability since 2020 to look at RAG technologies, which I'm going to be talking about a little later this afternoon in a panel with Bremen Vance and Giuseppe Ghetto, in which we talk about these intricacies. But RAG allows us to load in documents from our own document set to inform, in specific ways, local answers to questions you tend to want to give to a chatbot interface. And so you could drag a PDF into the window for ChatGPT, and it will then take its answers. It will use the LLM model on the back end to read that document and parse it, and then it will use that back-end model informed by the data inside the document or set of documents to provide more specific answers. It seems to me this is likely where we're going to want to go for documentation that we bring to the web through chatbot interfaces. OpenAI Pro and Teams users, people who are paying $200 a month, get this pull-down menu available to them, which they can see, which gives them a set of the OpenAPI LLMs, and they can choose which one they want. The current new best one is GPT 4.5, but they have these reasoning models, which do a slightly different kind of answering questions than the top models. And the ability to choose from those begins to hint at an enormous complexity and sophistication in the sorts of information we can get from these systems. But for those of you who've used ChatGPT in its free form, one of the things that happens when you begin to use the more advanced features on these cloud services is that they get more expensive. OpenAI has a pricing model page, which many of you have never come across, but which is very important to researchers who are working on building with these back-end APIs inside of our documentation systems, and for anybody who wants to do those in a substantive way. GPT 4.5 model is the most expensive of those. They'll charge $75 per million tokens for input tokens and $150 per million tokens for output tokens. I'm going to be showing you some research I'm doing right now in which I set the context for my chat engine, which is not using OpenAI, at 16,384 tokens as the max for an answer. And that means about 100 answers may add up pretty quickly to being about 1 million tokens. So the price can get high very quickly, particularly if you're an organization or a large scale entity trying to employ these cloud GenAIs inside of your documentation plans. But it is a pretty simple interface. They've just got a website they can go to. They can pick from any of the backend models they want to use. They can drag in RAGs, and the system will answer their questions in ways that make them feel like it's a lovely shining light in our lives. But the serious users of GenAIs are interacting with systems, with the backend systems like the OpenAI ones, through these APIs. You can build a program or a website using your own web technology or your own app technology. And then you send in a standard format in the API I've got here. This is with the OpenAI interface, in which you tell it which model you want it to use. You tell it the temperature you want it to give you for its responses from 0 to 1. 0 being a very literal, direct answer, 1 being a much more creative and innovative answer. But when you control the temperature, you can control how likely it is to hallucinate in some ways. We could tell it what the maximum number of tokens is it can use when it's figuring out how much it wants to answer. That's how much money you're willing to pay per query. We could specify statistical numbers like the top K and the top P. These are a little more technical that I want to go into today, but I find them fascinating, and they're really not that complicated of mathematics. If you had a course in graduate school on statistics, you'll find that when you go back into these, they're not that complicated. The formulas are fairly familiar. They sound scary, but they're not as bad as you'd think. And then you put in your user ID and your password, and it then charges to your account every answer that gets produced. Do you think people are really doing this? They are. I've got a chart here from OpenAI's documentation in which they talk about various sorts of temperature and top P settings. So they talk about how if you're doing code generation, you might want to set a temperature of 0.2. That'll keep the system very literal, and give it a top P of 0.1. That's going to make it pick the very top answer that it finds when it begins to randomly generate possible answers to your question. And then it might produce programming code for you to answer your question that's very literally, very specifically, very detailed, and not very imaginative. For creative writing, they suggest you might want to go to a 0.7 for your temperature and maybe a top P of 0.8. You could see these sorts of settings are things which advanced users of GenAIs need to think about, and which most users don't ever need to know or see at all. All right, do these things really exist? Well, yes, they do. In fact, I can point here to a piece. There's a forthcoming peer-reviewed article about it coming out soon. This was developed by our colleagues in TechCom at Arizona State University, working in conjunction with some folks in water management at Arizona State. They've built a chatbot for water issues for people in the state of Arizona. I've worked with it fairly extensively, and you can ask it questions about water, and it will then begin to inform people in common, regular, everyday language about issues of water, freshwater management, and the reasons why the state has to allocate and manage water the way it does, in ways that'll answer whatever question the user comes up with for as long as they choose to question it. And it will then begin to convey to people from RAG documents that they've loaded into the system, heavily informed by those, running in this case on a web front end that's in AWS, which is Amazon's cloud server. And I'm not sure what their backend GenAI is, but let's assume for a second it's OpenAI. You can ask it as many questions as you like. It'll use the GenAI, it'll refer to its RAG documents, and it will then produce answers in ways that I think are quite promising for our field. All right, I don't want to be an advertiser for OpenAI. I don't like them very much. They're not my favorite company in the world. So I can show you, if you were to use Anthropic's Claude, for instance, and you pick a model like Claude Sonnet 3.7, their new high-end model, the interface works almost identically. You got your web browser, you type in Claude.ai, you can load RAGs into it by just dragging them into the browser window. And then if you have more advanced uses, you can choose from various of the Claude engines, the older Claude 3 Opus or the Claude Haiku. And these allow you to do some settings for adjustments, for differences, different costs in a model that's remarkably similar to the one that OpenAI uses. And there are API access to Claude. So you can use the Claude OpenAI, use the Claude AI API, which is remarkably similar to the one, if you look at the documentation, to the one used by OpenAI. So you can specify a temperature for the answers that you want, the maximum tokens you want it to use, the top K and the top B. And you then again put in your Anthropic user ID and password, and they'll bill it to your account. I've been looking at the Case Western Reserve University's prototype of an advising system for their students. This is the web interface to it. I'm afraid I'm under NDA, so I can't really talk about what happens when you click that sign in button, and I can't show you examples of what the system looks like right now. But they're building a system designed to help students by allowing them to ask questions which are informed by RAG information about how students can proceed successfully through a university. The social justice movement in TechCom has suggested we need to think about things about our users in more specific ways, and first-generation college students and ESL college students might benefit enormously from a chatbot interface, particularly one that can handle more languages than simply English. This leads me to the third relationship, the one I want to advocate for, the FOG GenAI. So if you're not familiar with the term, fog computing, I've got here the NIST paper from 2018 that sort of debuted the term, involves taking cloud technologies like containerization, the sorts of systems that run GenAIs and run the websites that provide them, and lowering them down to ground level, running them ourselves on our own local boxes or on our own universities, instead of sending the data to cloud service providers. Fog computing suggests that we use the same technologies, the same engines, the same LLMs perhaps even, and lower them down and run them in our own local context. Then we can provide them with more detailed RAG information that we don't generally put out to the public, for instance. And we can build systems for our local users that benefit from all of the chat interface elements without needing to use OpenAI or Anthropic or those cloud service providers. Those of you who've known me for a long time will say, oh, Jeff. And here I'm going to suggest some free and open source technologies that you can implement in your own local environments. One of the leading web front ends these days, Open Web UI, you can install using any container technology, or you can just run a command line on your computer. I've got a command line at the bottom of the screen here, which is a single Docker command line. If you have Docker installed on your server, Docker is a cloud, it's a containerization technology that's used a lot in web these days. I have Docker running on a machine in my media lab, and I typed this command into it, and it loaded and started an Open Web UI server running on my computer in my lab. That one command allowed me to do that. I got my first one up and running in a couple of minutes. It took me some customization of that command to build one that I really liked, but I'll show you that one in a few minutes. Similarly, there's an open source and free backend GenAI model, which can load LLMs of all different sorts. This one I'm going to recommend is called Ollama. I've been running it for about 1.5 years now. I built a first model in my laundry room at home. And then now that I've built up my English media lab next door here at Texas Tech, I've got some higher end computers that can run Ollama and run it with surprising effectiveness. I'm getting a question from the chat that asks how much of a safety net RAG gives us when we're setting up an in-house system. I'm going to ask you to give me a second on this because there's a surprising answer to this, which comes from the stuff I've been saying up till now. Give me a sec. I'm going to get there soon. Okay, so many of you may have heard from open source advocates in the past who've suggested, you've heard people advocate for using open source technologies of all different kinds, and many of you have maybe tried them, but you've always ended up going back to the Microsoft Office or the Google Docs or whatever corporate system we have available to us. There is a cliche of an open source advocate, which those of you who know me know how much I hate cliches. I don't want to be a cliche in any way. So I've got some articles here that are talking about the ways in which these containerization technologies, because they're much more complicated and much more sophisticated, but because they're also easy to implement on your own computers, have led to a fairly widespread set of changes in the literature that I'm seeing among AI researchers. In 2023, 80 to 90% of companies were heavily invested in closed source GenAI systems like OpenAI. But articles like this one from March 21st of 2024 began to see that as many as 46% of respondents were strongly interested in and would prefer to have open source models running in-house that they could control themselves rather than using these cloud services. One of the things you'll find is that cloud services offer this free version that's very pleasant at first, but then when you start to do complex and sophisticated stuff with it on a broad basis, the costs start to go up enormously. We've all found that the costs of cloud technologies are much more expensive than the salespeople at first suggested they might be. Control, security of the proprietary data in our documentation sets, and understanding why the models do what they do, and the ability to customize things like temperature, top P, top K, and other parameters completely makes these sorts of systems look far more attractive to a lot of organizations. Is it possible to do them? Well, yeah, I mean, Ollama lets us do this. I've got a command here down at the bottom of the screen. This is a Linux command if you have a Linux computer, or you could type it in on Macintosh. I've ran it on a Macintosh. And when I type that command in, it would install Ollama on my computer, and I can get Ollama running. Okay, so, sorry, I'm going up instead of down. If we think about a fog services architecture, then we can build our own server in which our users use their same old laptop. They connect to an interface which is being provided by Open Web UI, which looks remarkably like ChatGPT out of the box, and which we can control completely ourselves to build any interface we like. It then connects on the back end to the OpenAI, to the Ollama model, whichever model we load into it, and you can drag RAG documents right into the web browser window. Open Web UI can connect as well to OpenAI if you want to have it use GPT, or it can connect to Sonnet if you want to have it use that. Gemini, the Google system has a new model that just came out this week, and you can connect to the Gemini model using these open APIs. And so you could build your own web server, put your own brand on it, load your own RAG documents into that, and then send back-end processing for the chatbot interface to any dominant cloud provider if you really wanted to do that. But you don't have to. There are many, many, many models, open models for Ollama. The new Google Gemini 2.5 has also been released in a free open model called Gemma 3. Some of you may have heard of DeepSeek, the last month's model, the gigantic new model, the 641 billion parameter model, which is open source and free, and which is provided by a company in China. You can load that immediately on your Ollama box. I've got it running on mine. Or we can use Microsoft's 5.4. Ollama has a list of open LLMs you can install on your own server, and there are really dozens of them. I've run as many as quite a few on my own systems. If we look at my home laundry room system, I queried it yesterday, and it looks like I'm running 13 of them right now on my home system. And this is built out of chewing gum and aluminum foil and little computers I've got lying around in my house. And it does a decent job. We've been running user subjects on it. It answers the questions. All right. So I don't like to get too abstract. Let me take you through one case study. I'm going to talk to you a bit about an article that I'm writing right now with Bremen Vance and Giuseppe Ghetto, and we'll take a look at one of the ways in which this could impact TechCom scholars and researchers. I'm going to start with the problem of my own department's graduate studies handbook. I'm not attacking my own department. I've been in a number of different departments, and we found this problem in all the graduate handbooks. I spent 20 years at Iowa State University, where we had a graduate handbook that had exactly the same problems almost entirely. What we had wasn't, what we have here at Texas Tech, I'll say, is an 87-page PDF graduate manual. It's got the policies and procedures for graduate students and all the things they need to do in order to reach their degree, their master's or their PhD. But the documentation is written in a bureaucratese, which is fairly impenetrable. And there are reasons why it's written in the way it is. The instructions in the pages for how, for instance, stipends are awarded to some graduate students and the ways in which we allocate those needs to be written in a legalese that prevents us from facing things like lawsuits from graduate students who feel that stipends were awarded to some people and not to others for reasons that are going to be problematic. The legalese documentation is required by university administrations who check and standardize the graduate handbooks across all the departments at a university. Yes, Eugene's appreciating the nerdery of this talk. I'm glad people appreciate when I get into this detail. Okay, so I've got this problem, which is we have a graduate handbook. What we found was that lots of grad students weren't reading it very carefully, or they weren't able to find the pages they needed to find for their things. So instead, what they mostly did was they either tried to search, which worked okay if they got the exact wording right for the phrase they were looking for inside the handbook, but sometimes led them to a page about the creative writing program instead of the page about the technical writing program. That's a problem. Or if they didn't type in the exact phrase, qualifying exam, for instance, they wouldn't find the pages about our qualifying exam. Some people were looking for a comprehensive exam and they couldn't find anything at all. Search is problematic. Browsing is problematic. What I've found over the course of my career teaching graduate students is that often graduate students just ask senior graduate students how to do things. And the senior graduate students are going to answer based on the rules and policies as they were told them or as they understood them, which might have actually changed over the course of years. What we have is unreadable documentation, which nobody likes, but which has to be written in the way it's written to some degree. What's the answer to this question? Well, my colleagues and I are theorizing it might be a chatbot, exactly as I've suggested here today. So here's what happens if you ask ChatGPT. In this case, I've got a sample query. How does a Texas Tech TCR, that's our Tech Common Rhetoric program, PhD student, add a dissertation committee member who's not in the TTU English department? And you can't really read the answer here, but you can see that ChatGPT gave us 3 paragraphs and a 4-bullet numbered list with boldface. That is very abstract. It's from a couple of web pages that exist on the Texas Tech website, but our graduate handbook is a PDF which we don't put on our public website. It's an internal documentation system. It's available to all of our graduate students when they log in with their user accounts. They can get to the PDF documentation, but ChatGPT can't see it. And as a result, ChatGPT's answers to this are not very good. But we know graduate students might be going to a chatbot to ask it these questions because they love ChatGPT. One way we can ameliorate this a bit is by adding RAG data. So a grad student could upload the PDF of the graduate handbook into ChatGPT and then ask the exact same question. And what you'll get is a much different answer from GPT. It gives us a 4-part bulleted piece with a couple of important considerations, but it names, for instance, the associate dean to whom you have to write a memo if you want the exception to add a non-TTU English faculty member to your committee. It has her name and has the details of things that it gleaned from the RAG data from the PDF of the documentation. It does have some confusing organization towards the bottom where it suggests something that's not actually an answer to the question. So there's still some hallucination-ish behavior happening inside of ChatGPT. But one of my theories on the basis of my work with LLMs is that part of this comes from the enormous size of the GPT LLM. If we load a smaller LLM in, one of the open source ones, maybe an 8 billion parameter model, or a 22 billion parameter model, or a 27 billion parameter model, maybe a 34 billion parameter model, the LLM is going to have less information that will conflict with the RAG. And if we load a small LLM with RAG data documentation, what you tend to get then are much more detailed, much more focused, much more accurate, and much more useful answers to the question. Here's a screen from our prototype. I'm giving you some advanced look at our CDQ article, which has been accepted for an open, for a special topics issue upcoming. But I'll show you that with parameters like loading the GEMMA 3 engine, the 27B engine, loading the RAG for the documentation to the system, I've built this into my home front end so that that RAG is always loaded when you connect to the grad studies LLM on my home system. It's already loaded the RAG stuff, so the RAG stuff is already in the system. Grad students can simply connect to this, log in with a username and password that we provide, and then they can ask their question. And look, it gives a 2-paragraph answer. The answer gives the name of the people you need to talk to. It gives the details for the procedures in a short, concise, effective, and accurate mode. Now this is with GEMMA 3 27B with a temperature setting of 0.0. That's its most literal, briefest, most focused kind of answer. If I load into that system a temperature of 1.0, it's more storytelling form, it's more imaginative and more creative form. It gives me a little bit more detail. It gives me a slightly longer answer with some reworded sentences. The sentences are a little bit more charming, a little bit more engaging, but for the most part, it keeps the focus of the answers pretty much straight there. With the same LLM at a temperature of 1.0, I can get a more charming, but also fairly reliable answer to my questions in this case. If I load in the Mistral Small 24B, I like the Mistral model. It comes from Europe, and it's better with a bunch of non-English languages. So we begin to introduce the possibility that we can query the system in other languages. It gives me an answer that looks like this with a temperature of 0.0. Kind of like the ChatGPT, it gives me a short one sentence top, then 4 heading bulleted lists with the detail of the person you have to send the memo to, and then a 1-sentence conclusion to that. Mistral Small is looking pretty promising to me. If I give it a temperature of 0.8, instead of 1 sentence at the top and 1 sentence at the bottom, it gives me 5 bold-faced answers, adding save letter and put it in your files, which is a useful answer there, and adds a paragraph at the bottom that provides, a more detailed answer that's entirely accurate, I think, but pretty impressive. Okay, you want to get more impressive than that? We can load in the Phi engine. This is a 14B engine. This is a smaller engine, so it's faster. And this is a Microsoft open LLM, so it's free. It provides heavily bold-faced numbered lists of things to do. It provides, I think, in many ways, the best answer to my question. It's only a 14 billion parameter model, so it runs really quickly on my servers, on my little Macintoshes that are running, Macintoshes and Windows computers that are running this. But it provides answers that I think are going to be highly credible. Now, in the study that Dr. Vance and Dr. Ghetto and I are doing, we're going to have multiple coders coding the quality of these responses. And we'll take a look at, make an argument for the need for our field to develop a set of best practices for temperature settings, for top K settings, for top P settings, and for LLMs, which might help us begin to develop best practices that others could then replicate quickly and easily in their own contexts. All right. Now, I'm at an Hispanic serving institution. So one of the things I did here with the 514B model, trying Microsoft's vaunted and much self-proclaimed skills with languages, I asked it the same question in Spanish. And I suggested, por favor, responde solo en español. So I asked it to answer me in Spanish. I can develop some settings that tell it to answer in the language you asked it in. But in this case, I ask in Spanish the question about adding dissertation members to your committee, and it replies with an answer that, okay, my Spanish is un poco. My Spanish isn't great, but I used a colleague to look at it with me, and I used Google Translate to check the answers. The answer is pretty much a fairly literal translation by the built-in LLM with no additional software at all, so that students could ask in their own first languages questions from a bureaucracy's English language, difficult policies and procedures manual, and it then provides answers in their language. I've got a lot of West African students from Ghana and Nigeria. So in this case, I tried giving it a question in Yoruba. I've talked about this a bit on social media. Some of you may have seen this. Microsoft's 514B is much more concise than Yoruba, and it's not as focused in its answers. Its first part of the answer says, I'm sorry, I don't speak Yoruba very well, but here's my best attempt to do it, which is polite but unhelpful. And its answers aren't as good. But West African, Nigerian, in this case, Nigerian language, can be supported by these LLMs out of the box. And with fine tuning and adjustments to our settings, I suspect we'll be able to make them do fairly high quality work. Okay, I'm hoping that I've got you excited that these systems are buildable. Could you really build one of these yourself? In 2011, I published an article in Intercom that suggested we need multimedia labs in TechCom programs. And I showed one that I'd built at Iowa State University. In these, we'd put high-end computers, and I argued at the time that many of us have students who aren't wealthy. Students who have their own personal laptops might not be able to do high-end multimedia production or editing with the kinds of computers they can afford. And in order to keep our universities and in order to keep our TechCom programs more egalitarian and more focused on social justice concerns, we should have spaces that are open 24/7 to a door code where students and faculty, where people in our programs can go for higher end computer systems. Now, I think in a lot of ways, COVID messed up a lot of these media labs. Everybody retreated to our houses and we focused on our own personal laptops. And I'm finding my students very much want to use their own laptop for solutions to things. That's part of the reason why the cloud system that's led to the oligarchy of having the big cloud servers has gotten the way it is. But if your program has a media lab, as mine does, and we buy high-end computers for those spaces, one of the things I've discovered is that I can put my LLM open source servers right on these machines. If you take a little bit of care when you're buying and speccing the machines, you'll see here in this picture a Mac Studio on the left-hand side and an Alienware R16 on the right-hand side. These are the two multimedia computers in my multimedia lab now, and they're both running in the background as soon as they're turned on, the Olama backend model. I can then put on a separate machine in my office, a front-end web server, and voila, I've got an open LLM system, which works. There's a slightly technical diagram for how it works. In this case, I've got a front-end model, which then queries both of the back-end machines to see which one is busier. And when somebody types a question into the chat, it then sends it to whichever computer is less busy. So if somebody's sitting down at one of the computers and working on it for multimedia production, it sends it to the other computer. And it can still work even if there's some multimedia production being done by somebody sitting at the computer. This system works pretty effectively. What I want to suggest is that we need to be able to experiment with this. Not because it's important that we build our own systems or that open source is more virtuous, though the Mac Studio here on the left-hand side is designed to run at 8 watts when idle, and it pulls no more than 65 watts when it's running at max capacity. 8 watts is what a modern light bulb looks like when it's turned on. 65 watts is what light bulbs looked like when I was a kid. It's not an environmentally catastrophic problem. And the data on my systems, when my graduate students type these in, doesn't go anywhere outside of these two computers. And they're locked in a space that only I can get to. And as long as we set up policies and procedures to protect people's privacy, there's no sending of data to some remote and menacing cloud server somewhere. We aren't reliant on them. We could build these systems using small LLMs and with RAG systems. And because, as I've found, the smaller the LLM is, the more focused and responsive its answers are. And with the RAG, if we build the RAG system to be properly set up, we can actually build documentation systems at virtually no cost. I got a couple slides here I'm going to skip over quickly. There's a new DeepSeek that came out. There's an article here from yesterday that suggests that the new DeepSeek v3 tests at a model that puts it above GPT 4.5. This is a Chinese-based open LLM you can put on your local system if you want to. And there's an article here that they loaded DeepSeek v3 onto a Mac Studio, onto a high-end Mac Studio, and got 20 tokens per second, which is a pretty good answer. That's medium slow typing. It's medium fast typing. It would type your answer just about as quickly as you could type in a question to it. So this looks like a sustainable model for even the smartest LLMs. And on the small little models I'm working with, it's quite sustainable. Okay, what I want to suggest is all of those intricacies, all of those details about temperature, top P, top K, all of those things are things that we experiment with in detail when we use fog computing. When we load the server ourselves, we get more exposure to it than the hidden sort of simple web interface that ChatGPT gives us. And that rather than attempting to theorize these things by just looking at the ChatGPT screen and then attempting to model what we should do with response to those things, taking these things into our own hands and increasing our understanding of how the LLMs work and how we can customize them and how we can produce optimized RAG systems to produce documentation systems is going to be a promising future direction for researchers and for teachers in our field. Thank you.